Hi, this is the first video on our chapter on probability. And before we get into all the different ways of calculating probability, today we are going to look at different notations for sample space. So in probability, our sample space, it's also called the universal set, and that's all the possible outcomes. So for this example, my universal set, which is usually labeled with a U. It could be other letters as well. All my possible outcomes are 2, 4, 5, 6, 7, and 8. Now, if I want a smaller set, and for probability, those would be the favorable ones. Or let's say I'm playing a game, and if I get a 2 or a 7, I win. Those are the favorable outcomes. So I use the brackets, same as in my set, and this is a smaller set to indicate that 2 and 7 are both included in the bigger set. We use this symbol that kind of looks like a C. And the way I try and remember it is the C says 2 and 7 is contained within my universal set of all the outcomes. And down here, this one looks like an E because that's an element. So 2 without the brackets. With the brackets, it's a set. Without the brackets, it's just an element. So 2 is an element. I could also say 5 or 6 or any one of these single numbers are all elements of this set. And we have a few more symbols that we're going to talk about. So the first one is a union. And the union is a U. So this is my set A, union B. And what that means is it means all of the elements that are in A or B. And the way I try and remember this is a union. If you've ever heard of a wedding, be called a union. Well, all the people that the bride wants to invite and all the people that the groom wants to invite come together. And so it's all the people that are friends with A or B. So all of those people together. I just join them together. This symbol is basically an upside down U. And I remember the U is for union. The one that's upside down kind of looks like an N in the word intersection, or in the middle of the word and. These are the elements where they intersect. These are the elements that they have in common. So all the elements that are in A and in B. So think of an intersection of the road, and that's where the two roads intersect or overlap, where they have common ground. The other symbol that we're going to be talking about is a complement. And this basically means not. So the complement of A are all of the elements that are not in A. So whenever you see the symbol, just insert the word not. So all the elements that are not in A. MathXL uses this apostrophe symbol, so I just want to go over that, but this is the more widely accepted complement symbol. And finally, we have what's called the empty set. So if we're talking about our union or intersection, what they have in common, and they don't have anything in common, we can write the empty set as the brackets to indicate that it's a set with nothing inside. Or we have this symbol, which means there's nothing, so it's the empty set. All right, so that takes us to this first example. And I have set A as being 2, 4, 5, 6, 7, and 8, and set B as being 3, 7, 8, and 9. So here are a few questions. What is A union B? And those are all the elements that A and B both have in common. So we have the 2, the 3, the 4, the 5, the 6, the 7. I only write it once. The 8 I only write once, and I have the 9. So all of those are joined together. I only write the elements that appear both places once. All right, so this next question, what is A intersect B? Those are all of the elements that A and B have in common. So that's the 7 and 8 that are in both sets of brackets. And this final question says, what is A intersect with not B? So those are all of the elements that are in A and not in B. And those elements are 2, 4, 5, and 6. The 7 and 8 are listed over here, and that's all of the elements that are in A and not in B. All right, so now we're going to talk about probability. And it says, let H stand for getting heads on a coin. So if we flip a coin, down here, this notation, this P, whenever you see this, that means the probability. So this is, what is the probability of getting heads when I flip a coin? Now there are a few different ways that I can write this. I know that there's only one head on the two sides of a coin, so it's 1/2. If I'm asked to write it as a decimal, then I would take 1 and divide by 2, and I'd get 0.5. If I'm asked to write it as a percent, then I move my decimal 2 places, and that is 50%. So you're going to have to read MathXL or the questions on the tests and quizzes to see how they want you to format your answer. And now, the question says, is this likely, unlikely, or as likely as not? And basically, these pretty much mean what you think. It's likely if its probability is greater than 50%. Unlikely if it's less than 50%. And as likely as not if our probability is 50%, which is this example. So this one would be as likely as not, or it might also be worded as equally likely and unlikely. All right, for this next example, suppose that I have a 6-sided die. So that's just a normal die, and die is singular for dice. Define M as rolling a multiple of 3. What is my sample space or universal set? And remember, universal set and sample space mean all of the possible outcomes. To indicate that it's a set, I have to use these curly brackets. And on a 6-sided die, I could end up with a 1, 2, 3, 4, 5, or 6. Right? And then the next question says, what would my subset be? So that means, what are the favorable outcomes? What are the outcomes on the die that are a multiple of 3? So on this die, 3 is a multiple of 3, and so is 6. So that is my subset. Then it says, what is the probability that I roll a multiple of 3? Since we're talking about probability, there are 2 multiples of 3 out of the 6 possible outcomes, and we're going to reduce that to make it 1/3. Or again, I could turn it into a decimal or a percent. And the final question says, is this likely, unlikely, or as likely as not? And 1/3 is less than a half, or less than 50%. It's about 33% repeating with the 0.3s, and that makes it unlikely. Not impossible, just probably not what's going to happen, but it could. Right, so these have been the subset notation notes. If you have any questions on these, let me know. And now we will move on to Venn diagrams. Right, so a Venn diagram in math is the same as what you would have done in either a science class or a social studies class or an English class. This blue circle are all of the elements that are in A. So that will be 1, 2, and 3. This red circle is all the elements that are in B, which are 3 and 4. This part where they overlap is what they have in common. So that's 3 is in both A and B. And outside of here, we have 5 and 6. So those are not in A and they are not in B. So now we're going to go back through these same symbols. So this is A union B. This is A intersect B. This is not A. And this is all the elements that are not in A or in B. So these can be ors. The ones that look like ends are ands. All right, so we can run through these. These are the elements that are in A or B. So that's the 1, 2, 3, and 4. Those are all in A or B. I only write the 3 once. These are the elements that are in A and B, so that's where they overlap, and that's the 3. Not in A, so I have 4, 5, and 6, all except for these 3. And these are the elements that are in not in A or B. Up here I have the A or B, so that takes out 1, 2, 3, 4. These have to be the others, which are 5 and 6. And this is our final example. We're going to fill out a Venn diagram. So it says out of 40 students, 14 students are taking English, 14 total students, and 29 total students are taking chemistry. 5 of those students are in both classes. So down here I have this circle for English, this circle for chemistry, and in here is where they overlap. And since there are 5 students in both, I'm going to put a 5 in there. I have 14 total students in English. So here's 5 of them. So that means there are 9 left. And 29 total students in chemistry. So here's 5, so that leaves 24 of these people left. Now, there's 40 students total. I have 29, 38 of them accounted for. So that means there are 2 students that are not taking either of these classes. So I'm going to give you a second to answer these questions. All right, so how many students are in neither class? Well, that's the 2 that are left over after I've accounted for all of my other students. How many students are in either class? So in English or chemistry. Those are the 38 students that make up this part in here. This says, what is the probability of picking somebody that is in chemistry? Well, there are 29 students when I put these two together. There are 29 students out of the 40 students, so 29 out of 40. And again, it's just depending on how I'm asked to format that, either as a percent or a decimal. And finally, what is the probability of a student being in English and chemistry? These are the 5 students that are in both, 5 out of 40, which reduces to 1/8, or I could put it as a decimal or a percent. So hopefully this helps you with the notation and the symbols and Venn diagrams. If you have any questions, ask me in class.